After studying this chapter, you will be able to recognize refillable, non-refillable, and recovery cylinders. You'll be able to explain the cylinder capacity and cylinder colors. Know the difference between pure azeotropic and zeotropic refrigerants. Understand R numbers, EPA identification, and refrigerant application. You use proper procedure to avoid refrigerant hazards. You'll use a saturation card for converting pressure and temperature. Refrigerants are packaged in disposable and refillable cylinders of various sizes that must meet Department of Transportation specifications. Refrigerants are the vital working fluids necessary in all refrigeration systems. Each refrigerant is a special chemical designed for a particular application, and new refrigerants are being discovered every day. Refillable cylinders are heavy-duty and made for repeated use. They must be tested every 5 years, and each cylinder is assigned a specific color. Do not trust the cylinder color because blue has many different shades. The trade name and R number are prominently displayed on each cylinder. Recovery cylinders are rugged and refillable. The EPA has specified the color code to be yellow tops and shoulders with gray bottoms. These recovery cylinders have 2 valves for obtaining vapor or liquid without inverting the cylinder. Cylinders are full at 85% of total capacity. A minimum of 15% must be reserved for hydrostatic expansion of the liquid. A special cylinder valve with a long dip tube permits selection of either liquid or vapor while the cylinder remains upright. If the cylinder temperature rises to 165 degrees Fahrenheit, safety devices open to relieve the pressure. When a cylinder is overfilled, hydrostatic expansion may cause the cylinder to explode. Each cylinder is marked to indicate the R number and capacity in pounds when full, or 85%. Gross weight means cylinder and contents when full. Tare means cylinder weight only. Net means cylinder contents. Federal law prohibits refilling of disposable cylinders because it is dangerous. The steel is thin, untreated, and subject to rust from air and moisture. Throwaway cylinders are available in 30 or 50 pounds of refrigerant. Use the upright position to obtain vapor and invert the cylinder to obtain liquid. A pure refrigerant has one molecule type and does not change composition when boiling or condensing. An azeotrope is a mixture of 2 pure refrigerants combined to form a third unique refrigerant having its own individual characteristics. A zeotrope is a blend of 2 or 3 different refrigerants that do not form an azeotropic mixture. These new non-ozone depleting refrigerants do not have a specific pressure for each temperature. They exhibit both fractionation and temperature glide. The letter R placed in front of the category number indicates refrigerant. When a manufacturer introduces a new refrigerant within a series, it receives the next number within that series. If another manufacturer submits exactly the same components, it receives the same number. If the components are the same, but the weights by percentages are different, a letter of the alphabet is added at the end of the number. The use of these R numbers de-emphasizes individual brand names. Chlorofluorocarbon molecules are composed of chlorine, fluorine, and a carbon. These refrigerants are very stable and do not break up easily when released to the atmosphere. CFC molecules stay together for over 40 years and drift upward to the ozone layer before breaking up. The ozone layer protects the Earth from ultraviolet rays, and one chlorine atom can destroy 100,000 ozone molecules. Over 70 industrialized nations signed an agreement to stop making CFCs beginning January the 1st of 1996. Hydrochlorofluorocarbons are less stable than CFCs. and are less harmful to the atmosphere. HCFCs contain hydrogen, which makes the molecule less stable. HCFC molecules quickly break up when released to the atmosphere. On January the 1st, 2010, HCFCs cannot be used in new equipment. Production will continue until January the 1st, 2020 for service repair only. Hydrofluorocarbons do not contain chlorine, which destroys ozone. These refrigerants are considered environmentally safe. However, the EPA requires recovery of all refrigerants, even HFCs. Deliberate releasing of any refrigerant to the atmosphere is a violation of federal law involving the Clean Air Act, Section 608 or Section 609, enforced by the EPA. Most refrigerants are designed to operate within a specific temperature range or application. These applications are used when speaking about systems. For example, air conditioning is a high-temperature application, and the refrigerant of choice is R22. Therefore, anyone speaking about comfort cooling or air conditioning is automatically speaking about R22. The chart illustrates 6 basic applications and the most popular refrigerants for each application. The saturation card is used for converting refrigerant pressure to temperature or temperature to pressure. Raising or lowering refrigerant pressure also changes its temperature. These pocket-sized cards are free at your local supply house. Refrigerants have special characteristics. The chart shows how refrigerants are identified by R number, chemical name, and formula. Additional information provides the EPA type, the cylinder color, and boiling point and oil used. R11 is a low-pressure refrigerant used for 200-ton to 500-ton industrial centrifugal chiller systems. R11 is a synthetic refrigerant that is stable, non-flammable, and non-toxic. The systems are water-cooled and operate in a vacuum. The latent heat value is the difference between the heat content of the liquid and the vapor. The color code for R11 is orange, and the safety disc ruptures at 15 pounds, or 115 degrees Fahrenheit. Leaks are detected by soap bubbles, halide torch, electronic, or ultrasound. R12 is a colorless, non-toxic, non-corrosive, non-flammable synthetic refrigerant. It is an old and reliable refrigerant that came into general use in 1936. R12 dominated the medium temperature range. Its latent heat value is the difference between the last 2 columns of the table. And R12 leaks are detected by using soap bubbles, halide torch, electronic, dyes, or ultrasound. R134A was invented more than 20 years ago and is similar to R12. As an HFC, it is not scheduled for phase-out under current law. R134A is not a drop-in replacement for R12 and is not mixable with mineral oils or alkylbenzene lubricants. R134A requires polyester lubricant, which comes in several variations. Check with the compressor manufacturer for the proper lubricant. R22 made its debut in the 1940s. R22 is very efficient when applied to high-temperature applications and dominates the air conditioning market. R22 is stable, non-toxic, non-corrosive, non-irritating, and non-flammable. Because of its strong attraction to moisture, R22 requires the use of large filter dryers. R22 leaks are detected by using soap bubbles, halide torch, electronic, dyes, or ultrasound. Azeotropes fall into the R500 series of numbers. An azeotrope is a mixture of 2 pure refrigerants that combine to form a third refrigerant having its own individual characteristics. The manufacturing process is precise and the azeotropic mixture is patented. The service technician should never mix refrigerants for any reason. R502 was developed in 1961 and is an excellent refrigerant for low temperature applications. R502 has higher suction pressure at low temperature, improving oil return to the compressor. Leaks are detected with soap bubbles, halide torch, electronic dyes, or ultrasound. A proven replacement solution for R502 systems is R507 is an azeotrope and a non-ozone depleting refrigerant that possesses characteristics similar to R502. R507 is not a drop-in replacement because mineral oil and alkylbenzene lubricants are incompatible with R507. Leak detection is the same as R502. Refrigerant vapor is almost odorless and 5 times heavier than air. High accumulations will displace atmospheric air and prevent access to oxygen. Inhaling high concentrations of refrigerant vapors may cause unconsciousness, cardiac sensitization, heart irregularities, and death by asphyxia. Becoming lightheaded or dizzy is a warning that fresh air is required. Confined areas should be checked with a leak detector before entering. At high temperatures, refrigerants decompose to form hydrochloric acid, hydrofluoric acid, and phosgene gas. Phosgene gas is very toxic to humans. The atomic weight of ammonia is 17, so the R number is R717. The atomic weight of carbon dioxide is 44, so the number is R744. These refrigerants are expendable, with the liquid boiling at very low temperatures and the resulting vapor is released to the atmosphere. The EPA considers inorganic refrigerants as environmentally safe and does not require their recovery. Inorganic refrigerants are primarily used for fast freezing and cryogenic applications.